Hi friends, welcome back to my YouTube channel. So today I'm going to discuss about multiple axis technique, one of the multiple axis technique, frequency division multiple axis, Fdma. So previously we have discussed the introduction part of multiple axis. We already told that there are major wireless communication multiple axis techniques like CDMA, GDMA, Fdma, HDMA, etc. So today we are going to discuss about Fdma. So in later section we will discuss the other multiple axis techniques also. So now we can go to the video. So this is from the Advanced Communication System EC404 from module 6 from BTECH syllabus for Electronics and Communication Engineering students. So you can refer this for your exam and go and answer in a way that we can score much better score. So let's go to the video. So frequency division multiple axis. So as I said earlier, frequency division multiple axis assigns individual channels to individual users. So it can be seen from figure that each user is allocated a unique frequency band or a channel. So each user is for individual individual channel is there, and each user is allocated to a unique frequency band or channel. So if you see the figure for the Fdma, you see here it's a three-dimensional picture. So each user have individual channel for each user. So this is a figure for Fdma channel, Fdma multiple axis technique. So you can draw this figure in exam. This is very mandatory picture that you need to draw in your exams. So without this figure you will not get better score. So try to add this figure in the answer sheet also. So these channels are assigned on demand to users who request service. During the period of call, no other users can share the same frequency band. So once a user is requested a demand for a channel, then that during that period or that call, no other users can share the same frequency band. So in FDD systems, the users are assigned a channel as a pair of frequencies. One frequency is used for the forward channel while the other frequency is used for the reverse channel. So this is I have already discussed in the previous section also. FDD, they are bidirectional connection. One is for forward and another frequency is for reverse channel. So here we have individual frequency for individual user or individual channel for individual users. So once the user demand the frequency or the band, other users cannot access that particular frequency band. So the features of Fdma as follows. Fdma channel carries only one phone circuit at a time. And the second one is, if an Fdma channel is not in use, then it sits idle and cannot be used by other users to increase or share the capacity. It is essentially a wasted resource. So this is one of the disadvantages of a Fdma, because once the channel is not in use, it sits idle and cannot be used by other person, or that means it cannot increase or share the capacity of that particular channel or a frequency. So after the assignment of a voice channel, the base station and the mobile station simultaneously and continuously transmit simultaneously and continuously. So once the user demand for a channel or frequency, and the base station and the mobile station transmit simultaneously and continuously. The bandwidth of Fdma channels are relatively narrow, means 30 kHz, as each channel supports only one circuit per carrier. That is, Fdma is usually implemented in narrowband system. So we have already discussed we have two types of systems like narrowband and wideband. So in that, Fdma is related to narrowband system since the channels are relatively narrow. 30 kHz for each channel supports one circuit per carrier. The symbol time is larger as compared to the average delay spread, and this implies that the amount of inter-symbol interference is low, and thus the little or no equalization is required in Fdma narrowband system. So I think we will discuss this delay spread in more in detail in other section, and you can remember this point in your while you are writing your exam. The symbol time is larger as compared to the average delay spread, and this implies the amount of inter-symbol interference is low and thus a little or no equalization is required in FDMA narrowband system. So other features is like the complexity of FDMA mobile system is lower when compared to TDMA system. So the complexity is lower compared to TDMA system, though this is a change in digital signal processing method improve for TDMA. So since FDMA is a continuous transmission scheme, fewer bits are needed for overhead purpose such as synchronization and framing bits as compared to TDMA. So comparing to TDMA, the complexity is very less in FDMA, and also in FDMA it's a continuous transmission occurring in FDMA. So the fewer bits are needed for the synchronization and the framing bits comparable to TDMA. And FDMA systems have higher cell site system cost as compared to TDMA system. So FDMA system has higher cell site system cost compared to TDMA system because of the single channel per carrier design. So we have said that a user can only access one individual frequency if they demand, and no other users cannot access that particular frequency at the same time. So it's like the cost is very high comparable to TDMA because the single channel per carrier design and the need to use the costly band pass filter to eliminate spurious radiation at this base station. So it also using the costly band pass filter to eliminate spurious radiation at the base station. And the another feature is the FDMA mobile unit uses duplexer since both the transmitter and receiver operate at the same time. So this result in the increase of the cost of FDMA subscriber unit and base station. So this is already we have discussed in the previous section. FDMA uses duplex devices. Like in FTD they are using reverse and forward channel to transmit the signal from base station to mobile station. So for that it needs a device called duplexer. So it will transmit and receive simultaneously, and so that will increase the cost of FDMA subscriber unit and base station. So one of the disadvantages is this. And FDMA requires tight RF filtering to minimize adjacent channel interference. So if you remember this word adjacent channel interference. We will discuss this in later section also. So FDMA requires tight RF filtering to minimize adjacent channel interference. So this is all the features of FDMA. So once you are writing, if you have a questions like FDMA, discuss or write about FDMA, you can mention all these points in the answer sheet, and also remember to draw the picture of the FDMA. So that is the important thing. Without that picture you will not get the highest score. So this is all about the FDMA features. And nonlinear effect in FDMA, you can ignore this part because this is not important, but I will tell you in a granular level. So in a FDMA system, many channels share the same antenna at the base station. The power amplifier or the power combiner, when operated at a near saturation for maximum power efficiency, are nonlinear. So in power amplifier or the power combiner where operated or a near saturated for maximum efficiency are nonlinear. These nonlinearities cause signal spreading in the frequency domain and generate intermodulation frequency. So IM frequency. So it will create the intermodulation frequency, and IM is desired RF radiation which can interfere with other channels in FDMA system. So these frequency can interfere in other channels frequency in FDMA system, and spreading of the spectrum result the adjacent channel interference. So this also causes the adjacent channel interference. So intermodulation is the generation of undesirable harmonics. So harmonics generated outside the mobile radio band cause interference to adjacent services, while those present inside the band cause interference to the other users in the mobile system. So this is the nonlinear effect in FDMA system. So the overall thing is that the base station is using antenna at the same time. I mean the many channels use the same antenna at the same time in the base station. So the power amplifier or the power combiner that is working in non-linearity, and the non-linearity causes the spreading of the signal in the frequencies domain and generate a frequency called intermodulation frequency. And these intermodulation frequencies undesired RF radiation. This is not required, and this will interfere the other channels in the FDMA system, and the spreading of the spectrum result adjacent channel interference. And the intermodulation is the generation of undesirable harmonics, and harmonics generated outside the mobile radio station will cause or will interfere the adjacent services, while those present inside the band cause interference to the other user in the mobile system. So this is a nonlinear effect in the FDMA. So you can mention this also while writing your exam answer sheet. And for example, it's a question, you can ignore this part also, just for your reference I am explaining this. Find the intermodulation frequency generated if a base station transmit the two carrier frequency at 1930 MHz and 1932 MHz that are amplified by a saturated clipping amplifier. If the mobile radio band is allocated to 9020 MHz to 9040 MHz, designated the IM frequency that lie inside and outside the band. So I think this you can ignore because this is not required for the exam. So if you have, you can refer these answers in the PPD. So in this video, so I am skipping this part. So next thing is that the first US analog cellular system, the Advanced Mobile Phone System AMPS, is based on FDMA by FDD. A single user occupies a single channel while the call is in progress, and the single channel is actually two simplex channel which are frequency duplexed with a 45 MHz split. So in AMPS, it is used one single user occupies the single channel while in the call in progress, and single channel is actually a two simplex channel where the frequency is duplexed with a 45 MHz split. So when a call is completed or when a handoff occurs, the channel is vacated so that another mobile subscriber may use it. Multiple or simultaneous users are accommodated in AMPS by giving each user a unique channel. Voice signals are sent on the forward channel from the base station to mobile unit, on the reverse channel from mobile unit to base station. So in AMPS, analog narrowband frequency modulation. In AMPS, analog narrowband frequency modulation (NBEM) is used to modulate the carrier. The number of channels that can be simultaneously supported in a FDMA system is given by N equal to BT minus 2 B guard by BC. So where BT is the total spectrum allocation and B guard is the guard band allocated at the edge of the allocated spectrum, and BC is the channel bandwidth. So you can also ignore this part, but if you can use, because in AMPS system it is using FDMA. So while you are writing your exam, give an example that Advanced Mobile Phone System AMPS using FDMA by TDD, and it is used analog narrowband frequency modulation to modulate the carrier, and the number of channels can be simultaneously supported in the FDMA system, and you can mention this equation as well and give the explanation to each terms in the equation. So this you can do. And I have already given that the figure of the FDMA system is very important. Time, code and frequency is three axes are there, and for each multiple axis techniques have different picture. You will get confused while seeing those picture, but mention that the channel is in between time and frequency axis. So you can remember like that, time and frequency axis, the channel is divided. And for example, for that equation, that N equal to BT minus B guard by BC, if BT is 12.5 MHz, B guard is 10 kHz and BC is 30 kHz, find the number of channels available in the FDMA system. This question you can expect from the exam. So the solution is very simple. You can apply the equation in the equation here and replace the values of BT, B guard, BC in the equation, and we will get 416 as the number of channels available in this FDMA system. So this is for an example for that equation. So that is all about today's. So Fdma is completed. You can have many more details regarding Fdma in different books and everything, but I am just strictly following the desired textbook that mentioned in the K2 syllabus. So you can refer this is the important things that is for Fdma. So next we are going to discuss about TDMA or CDMA and SDMA. So we will see in the next lessons, in the next video. So if you like this video, please share, subscribe and comment, and so put your comments in the comment box and let me know if you have any doubts or clarification needed. So thank you for watching my video. See you in the next video.